Imagine a world hidden within the asteroid belt, a place once dismissed as little more than a giant space rock. For centuries, astronomers knew it existed, but they had little idea what secrets it held beneath its ancient surface. That changed when NASA's Dawn spacecraft arrived, revealing discoveries that transformed our understanding of this distant dwarf planet. Ceres, discovered in 1801, is the largest object in the asteroid belt between Mars and Jupiter. Measuring about 940 kilometers across, it contains nearly one-third of the belt's total mass. Although it was originally classified as a planet, it is now recognized as the only dwarf planet in the inner solar system. In 2007, NASA launched the Dawn mission to study two remarkable worlds, Vesta and Ceres. Powered by highly efficient ion engines, Dawn became the first spacecraft to orbit two different extraterrestrial bodies during a single mission. After completing its investigation of Vesta, the spacecraft continued its journey towards Ceres, arriving in 2015. As Dawn approached, blurry telescope images gave way to detailed photographs of a rugged landscape filled with mountains, impact craters, and mysterious bright patches unlike anything previously seen on an asteroid. One crater immediately captured scientists' attention. Known as a Cater crater, it contained brilliant white regions that reflected sunlight much more strongly than the surrounding surface. Against Ceres' dark terrain, these bright areas almost appeared to glow from space, sparking enormous public curiosity. Early ideas varied widely. Some researchers suggested exposed water ice, while others proposed unusual minerals or lighting effects caused by the viewing angle. However, as Dawn moved closer and captured higher-resolution images, it became clear that these bright features were genuine geological formations. Spectroscopic measurements eventually identified the material as being rich in sodium carbonate, a highly reflective salt commonly associated with briny water on Earth. This finding dramatically changed scientists' view of Ceres. Rather than being a completely inactive world, Ceres appeared to have experienced geological processes capable of transporting salty water from beneath its surface. Researchers believe that underground reservoirs of liquid-rich brines slowly migrated upward through fractures created by ancient impacts. Once these salty fluids reached the surface, the water quickly evaporated into space, leaving behind brilliant white mineral deposits that remain visible today. This process resembles cryovolcanism, sometimes called ice volcanism. Unlike ordinary volcanoes that erupt molten rock, cryovolcanoes release mixtures of water, salts, ammonia, and other frozen compounds. Similar activity has been observed on icy moons such as Saturn's Enceladus, making Ceres one of the most intriguing worlds in the solar system. Within a Cater crater, scientists identified a central dome surrounded by fractures and extensive salt deposits, suggesting that material from deep underground may have reached the surface relatively recently in geological terms. These discoveries revealed that even a small dwarf planet could remain surprisingly active long after its formation. Instead of being a frozen relic from the solar system's past, Ceres appears to preserve evidence of internal processes that may still be continuing today. As scientists analyzed more data from the Dawn spacecraft, an even more fascinating picture of Ceres began to emerge. Some observations suggested that faint hazes occasionally appeared within a Cater crater before disappearing again. Although the exact cause remains under investigation, one possible explanation is that sunlight warms subsurface ice or briny deposits, allowing small amounts of water vapor to escape before quickly dispersing into space. If this interpretation is correct, it would indicate that Ceres is not entirely dormant. Instead, it may still experience subtle geological activity driven by pockets of salty liquid hidden beneath its crust. Researchers now think Ceres possesses a layered interior consisting of a rocky core surrounded by ice-rich material mixed with minerals and salts. Chemical compounds such as ammonia may help keep these underground brines from freezing completely, allowing liquid reservoirs to survive for extremely long periods. This possibility has major scientific implications. Liquid water is considered one of the essential ingredients for life as we know it. While no evidence of living organisms has ever been found on Ceres, environments containing liquid water, energy, and complex chemistry are considered promising places to investigate. On Earth, microscopic organisms thrive in extreme locations once believed to be completely uninhabitable, including deep underground, beneath Antarctic ice, and around hydrothermal vents on the ocean floor. These discoveries encourage scientists to keep an open mind when searching for potentially habitable environments elsewhere in the solar system. Ceres joins a growing list of intriguing worlds that includes Europa, Enceladus, Titan, and several other icy bodies where hidden oceans or subsurface liquids may exist. Perhaps the most important lesson from the Dawn mission is that planetary evolution is far more diverse than previously imagined. Small worlds once considered geologically dead may still possess active interiors, underground liquids, and surprisingly complex chemical environments billions of years after their formation. As for the famous bright spots that inspired headlines about mysterious lights, scientists have found no evidence that they are artificial. Extensive analysis strongly supports the conclusion that they are naturally occurring deposits of highly reflective salts left behind by ancient briny fluids. Although these formations can appear almost luminous in spacecraft images, their brightness is a remarkable example of geology rather than technology. Even so, the mystery captured the imagination of millions because it demonstrated how unfamiliar natural processes can sometimes resemble something extraordinary. When Dawn's fuel was finally exhausted in 2018, the spacecraft remained in permanent orbit around Ceres, where it will continue circling the dwarf planet for many years. Its mission may have ended, but its scientific legacy continues. The data returned by Dawn is still helping researchers investigate the history of water in the inner solar system, the evolution of dwarf planets, and the conditions that may allow habitable environments to develop beyond Earth. Ceres reminds us that even relatively small worlds can preserve enormous scientific mysteries. Every mission to places like this expands our understanding of how planets evolve, how water shapes distant environments, and where future discoveries about our cosmic neighborhood may still be waiting.